Round number to nearest integer. I've been trying to round long float numbers like, with no success so far. I tried math.ceilx, math.floorx, although that would round up or down, which is not what I'm looking for, and roundx, which didn't work either, still float numbers. What could I do? Code.
TL, Doctor. We'll round it and change it to integer. You are not assigning round h to any variable. When you call round h, it returns the integer number but does nothing else. You have to change that line for to assign the new value to h. As at Plowman said in the comments, Python's round doesn't work as one would normally expect, and that's because the way the number is stored as a variable is usually not the way you see it on screen. There are lots of answers that explain this behavior. One way to avoid this problem is to use the decimal as stated by this answer. In order for this answer to work properly without using extra libraries, it would be convenient to use a custom rounding function. I came up with the following solution, that as far as I tested avoided all the storing issues. It is based on using the string representation, obtained with repr, not str. It looks hacky, but it was the only way I found to solve all the cases. It works with both Python 2 and Python 3. Tests. Finally, the corrected answer would be tests. The gotcha here is that the dec th decimal can be 9, and if the dec plus 1 th digit equals 5, the 9 will become a 0 and a 1 should be carried to the dec 1 th digit. If we take this into consideration, we get in the situation described above, b equals 10 and the previous version would just concatenate a and b, which would result in a concatenation of 10 where the trailing 0 would disappear. This version transforms b to the right decimal place based on dec as a proper carry.
Use round x, y. It will round up your number up to your desired decimal place. For example,
round value, significant digit, is the ordinary solution. However, this does not operate as one would expect from a math perspective when round values ending in 5. If the 5 is in the digit just after the 1 you're rounded to, these values are only sometimes rounded up as expected, i.e. 8.005 rounding to 2 decimal digits gives 8.01. For certain values due to the quirks of floating point math, they are rounded down instead. Weird? Assuming your intent is to do the traditional rounding for statistics in the sciences, this is a handy wrapper to get the round function working as expected, needing to import extra stuff like decimal. Aha! So based on this we can make a function. Basically, this adds a value guaranteed to be smaller than the least given digit of the string you're trying to use round on. By adding that small quantity, it preserves round's behavior in most cases, while now ensuring if the digit inferior to the one being rounded to is 5 it rounds up, and if it is 4 it rounds down. The approach of using 10, ln val -1 was deliberate, as if the largest small number you can add to force the shift, while also ensuring that the value you add never changes the rounding even if the decimal dot is missing. I could use just 10, ln val, with a conditional if, val, 1, to subtract one more. But it's simpler to just always subtract the 1 as that won't change much the applicable range of decimal numbers this workaround can properly handle. This approach will fail if your values reaches the limits of the type. This will fail, but for nearly the entire range of valid decimal values it should work. You can also use the decimal library to accomplish this, but the wrapper I propose is simpler and may be preferred in some cases. Edit. Thanks BLCKKNGHT for pointing out that the 5 fringe case occurs only for certain values. Also, an earlier version of this answer wasn't explicit enough that the odd rounding behavior occurs only when the digit immediately inferior to the digit you're rounding to has a 5.
For positives, try. To make it work for negatives too, try. Int works like a floor function and hence you can exploit this property. This is definitely the fastest way.
If you want to see more, please consider subscribing.